3, scale diagrams. Scale diagrams can be enlargements, reductions, so enlargements meaning makes it larger, reductions meaning makes it smaller, or exact replicas, meaning it's the same size. To create a scale diagram, an appropriate scale should be determined. This is called the scale factor. Each dimension of the original object is affected the same by this number. So if I times one side by 3, I have to times the other side by 3 if my scale factor is indeed 3. Okay, let's take a look at an example. The a scale diagram of a skateboard uses a scale of 1 to 14. So at 1 to 14, every time we have a ratio, those are in the same units. Okay, what is the actual length of the skateboard given the diagram below? So if we have 1 centimeter of picture, that represents 14 centimeters of real life. Again, we're going to assume that the actual skateboard is going to be bigger than 5.5 centimeters. So that should then go with the picture, and then in real life it would be cross multiply 5.5 times 14 divided by 1, and you should get 77 centimeters in real life. Does that seem reasonable for a skateboard? Oh, yeah, it should. All right, so the scale factor represents the ratio of image, the length of the image, to the length of the same thing on the original. Okay, so remember that because this is the length of the skateboard in the picture, the 77 is the length of the skateboard in real life. Determine the scale factor. An easy way to determine the scale factor, we're going to use the letter small k, or lowercase k, used in a scale diagram. Here's the following guideline. K is equal to the diagram measurement divided by the actual measurement, or DOA, diagram over actual. Hopefully that's a way you can remember it. All right. An actual Canadian quarter has a diameter of 23.88 millimeters. Calculate the scale factor used to create the diagram of the quarter. Express the answer to the nearest tenth. Remember the tenth is 1 decimal place. A ruler is required to do this question. So, on your notes package, take out your ruler and measure the diameter of the quarter in your picture. Okay, try and get as close to the middle of it as you can. Okay, and I found mine to be about 15 millimeters or 1.5 centimeters. So we're looking for scale factor, so K is equal to diagram over actual. So in my diagram, I measured it to be 15, try that again, 15 millimeters. The actual quarter is 23.88 millimeters. So to the nearest tenth, to 1 decimal place, if you go 15 divided by 23.88, you should get 0.6. Again, feel free to turn off the video or pause the video and try this on your own calculator. How the scale factor affects their original shape. So here's some things to remember. If your scale factor is between 0 and 1, so such as 1/2 or 0.75, those are both between 0 and 1. That means the image is a reduction. Okay? If the scale factor is greater than 1, so such as 2 or 5.3, okay, those are both greater than 1, the image is an enlargement. I bet you can guess what the next one is. When the scale factor is 1, the image is an exact replica of the original. Okay, let's do some more examples. The Garry oak is a tree that is found on Vancouver Island. The original acorn for these scale diagrams was 1.9 centimeters long. Determine the scale factor that was used for each diagram. You will need to measure each acorn. Round each answer to the nearest tenth. So again, 1 decimal place, and don't forget you have to measure. So when you go to measure, you want to start here at the top and measure to here at the bottom. So you're looking at this distance right here on all 3 of your acorns. So if you would like to pause the video at this time and actually measure the length of your acorns, that would be awesome. Start her up again when you're ready to check your answers. Okay, so the scale factor again is diagram over actual. So in my diagram, I measured the first one to be 3.3 centimeters over the actual 1.9 centimeters, which was given in the question. To 1 decimal place, or nearest tenth, that works out to be 1.7. So that is an enlargement. It is bigger than the original. Same here, just diagram over actual. Okay, I measured the diagram to be 5 centimeters. The actual again was 1.9, so 5 divided by 1.9 is 2.6. Notice that there's no units on scale factor. Centimeters divided by centimeters, they cancel each other out and you have nothing left. Okay, so again, part B is an enlargement. Last, part C, diagram over actual. I measured this one to be 2.5 centimeters when the actual again was 1.9, so 2.5 divided by 1.9 is 1.3. So if you'll notice, C is approximately half of B. Okay, and if you look at the pictures, I could make that work. Absolutely. All right, good. So again, no units on your scale factors, please. Maybe make a note of that. Scale factors have no units. Okay. All right. Last ones. A couple more to go here. All right, we have a hex nut. Hex, of course, meaning 6 sides. So there's 6 sides on this nut. Must be enlarged by a scale factor of 250% for a display at a trade show. Now remember, we never work with things in percents. So 250%, we get dividing that by 100, and we get 2.5 as our scale factor. Okay? All right. So part A, take out your old ruler, measure the necessary distances on the diagram. So I think you should probably measure the inner diameter, okay, and pick some nice bright colors here. The diameter of the middle one, okay, good, and we'll go with a nice bright blue. The diameter of the outer circle, okay, and last but not least, what else can we use? Oh, how about yellow? All right, the length of the hex nut. Okay, and remember that this is a regular hex nut, so all of these should be the same. All right, so pause the video and come on back once you have all those measurements done. Okay? All right, part B. I got my inner, so diameter of the inner was 1.5 centimeters. Diameter of the middle I found to be 2.3 centimeters. The diameter of the outer worked out to be 3.2 centimeters. And the length of the hex nut, each side was 1.9 centimeters. Okay, so now we're going to figure out what the actual hex nut should be. Remember that this is the diagram, so K is equal to diagram over actual in each case. So if I'm looking for the actual, this is, so we are actually making a new diagram. So the ones that we have are the actual diagram. So therefore, how do I get rid of divide by actual? Well, I'm going to do the opposite, and I'm going to times both sides by actual. So diagram is going to equal to actual times our scale factor, which remember is 2.5. Okay, so let's figure out the diameter then of the inner. The inner is going to equal 1.5 times 2.5, which works out to be 3.75 centimeters. The diameter of the middle is 2.3 times 2.5, which works out to be 5.75 centimeters. The diameter of the outer was 3.2 times our scale factor of 2.5 is equal to 8.0 centimeters. So notice again it keeps getting bigger. And the length was 1.9, and again times 2.5, it should be enlarged, and that's 4.75 centimeters. All right, last example, and we're done this section. We have a billboard measuring 4.5 meters by 3.5 meters. We want the dimensions of a scale diagram of the billboard that would fit into a space 20 by 15. Okay, so if we did 1 to 1, that would fit, but not great. What if we went 1 to 2? Okay, so 1 meter is 2 centimeters. Sorry, yeah. So 1 meter, 2 centimeters, so that would be 9 and 7. So that's still going to fit pretty good. Okay, let's go 3. So that would be 13.5 by 10.5. That would still fit. Times by 4, so that would be 18 and 14. That would still fit. We times by 5, that would be 22.5 and 17.5, and that's going to be too big to fit in that space. So I think our scale factor is going to be, will be equals 1 meter is equal to 4 centimeters. Okay, so if we have 4 centimeters representing 1 meter, then if I have 4.5 meters, cross multiplying, that would give me 18 centimeters. And if I had 4 centimeters equals 1 meter, then if I had 3.5 meters on my billboard, then my diagram would show that it's 14 centimeters. And of course, that would fit in our space that we're provided. All right, for practice, I want you to go to 471 in your textbook and do questions 1, 2, 4, 8, and 16. All right, have fun.